Hi there, this video is on solving equations. So what we've got here is a couple of fractional equations and another equation that's got a few negatives in it. So let's have a look at this first one here. Remember, we want to get m all by itself and we're undoing operations by doing the opposite operation. With the negatives, just note that that negative there belongs to the 6 and that minus sign is associated with that 2m. So I've got negative 6 here, so I'm going to add 6 to both sides. So then those two cancel out to give 0 and I'm just left with negative or minus 2m here equals 10 plus 6 is 16. Okay, so that negative 2 is multiplying the m, so I'm going to divide both sides by negative 2. Okay, on the left hand side I'm just left with m is equal to 16 divided by negative 2 is negative 8. Okay, this second one here, a plus 2 over 2 equals 7. When you have fractions, what you want to do is look at the denominator, and if you've got a single algebraic fraction in the equation, what you can do is multiply everything through by whatever that denominator is. So what I'm going to do is multiply this side, that side by 2 and the right hand side by 2 as well. So I'm not changing the equation. So now what I've got is 2 times a plus 2 over 2. That multiplied by 2 cancels with that divide by 2 because you end up with just 1. So those two cancel each other out and I'm just left with a plus 2 on the left hand side is equal to 14. So another way of thinking about that is if I've got a plus 2 over 2 equals 7, this is divide by 2. So what I can do is take that over to the other side by multiplication. So essentially I'm still multiplying both sides by 2. So then that would become a plus 2 equals 14. So same thing. So now a is just equal to 12. Okay, this third example, we've got one fraction here. If I look at the denominator, it is 5. So to kind of deal with that fractional part, I'm going to multiply both sides by 5. Okay, so that whole side, just pop some brackets there. 5 times that side, and then 21 times 5. Okay, so multiplying both sides by 5. Now 5 times x divided by 5 will just give me x, because and essentially what I'm doing is I'm going 5 times x is 5x, so I end up with 5x divided by 5. So 5x divided by 5 is just 1x, which is just a single x. Plus, that 5 is also multiplying the 12, so you do need to do that multiplication. So 5 times 12 is 60, equals 21 times 5 is 105. Okay, so we can see now that x is equal to 105 subtract 60, which is 45. Okay, last question, a wee bit more complicated, but let's think about this. We've got two algebraic fractions, two fractions. When you've got this scenario happening, so you've got something over something is equal to another fraction, then we can do this thing called cross multiplying. So as long as both sides of the equation are fractions, we can, both sides of the equal sign, as long as that both are fractions, then that d there multiplies that a, that b multiplies that c. So we end up with a times d is equal to c times b. So this is called cross multiplying, and you can do that when both sides of the equal sign are fractions. So this 8 is going to multiply that side, and that 6 is going to multiply that expression there. So you'll end up with something looking like this. It's equal to 6 times that side, so you need the brackets there. And now we're going to multiply out these brackets. So 8 is multiplying everything inside those brackets. So 8 times 3x gives me 24x, plus 8 times 12 is, what's that, 96. Then we've got 6 times 9x, give me 54x, and then minus 6 times 4, which is 24. Okay, so now we've got x on both sides. We want to get our x's together. So I'm going to subtract 24x from both sides. So I end up with just 96 here equals 30x minus 24. Then I've got this plus 24 here. Minus 24. So I'm going to add 24 to both sides. Okay, so I get, what do I get here? 1120 is equal to 30x. So x is equal to, dividing both sides by 30. So 120 divided by 30 gives me 4.